All right, the session is now being recorded. Um, so I just want to give you guys a heads up about what to expect from here on out. So as you guys know, we are nearing the end, and we're nearing the end rapidly. Before I share my screen and show you guys what's in Schoology, there are a few important things I need to go over with you all first. So um, um, so in case you guys don't know, in exactly 2 weeks, we're going to be having our AP exams. Okay, so our AP exams start at DeSoto High School in 2 weeks. Um, for those of you guys who are taking the Physics 1 exam, the Physics 1 exam will be on Wednesday, May the 5th. So I'm going to go to the College Board website and I'm going to show you guys the schedule. Okay, so um, here is the 2021 AP exam schedule. So it's through the College Board website. Okay, if you click right here where it says View Exam Dates, as you guys can see right here where it says Physics 1 Algebra Base, that is scheduled for Wednesday, May 5th, and it is going to be at 12 p.m. Okay, so Wednesday, May 5th at 12 p.m. So, you know, um, a couple of important things I need to go over with you all. Um, so, guys, whenever you guys are coming in on that day to take your AP exam, every student must have an identification badge. Um, every student must have an updated identification badge. If you guys do not have an identification badge, they will not let you in the school. So, um, for those of you guys who don't have an identification badge for this year, you're going to need to come to the school and get one. Um, so, as you guys can see here on the email, I'm gonna zoom this in so y'all can see this. Uh, these are the times when you guys can come to the school to get your identification badge. Anytime between April 19th, which is today, and April the 30th. So the times that they're going to be handing these out are from 9 a.m. to 11 a.m. and also from 1 p.m. to 3 p.m. So if you come up to the school at any point during those times, you can get your identification badge. So if you look at the instructions right here, it says so this email that was sent to me to show you guys, it says please tell your students to come to door one entrance on Eagle Drive. When they enter, ask for Security Officer Mr. Roderick. He has agreed to assist our students with making the IDs during their following times. So again, you're going to need an identification badge because on May the 5th, you're going to need this ID badge to get in the school so that you can take your AP test. Okay? Um, so just guys, please be aware of that. Um, also, um, I want to let everybody know about the AP Daily Live Review videos that are currently available. That will be available on YouTube. Um, Let me go to that. Where's it? Okay. So I am going to send this link out in Schoology. Um, Now, guys, since we are in the final 2 weeks um, prior to the AP exam, this is a very, very good resource that I would use for those of you guys who want to get ready for the test and you're serious about this test. If you click here on this link where it says Physics 1, okay, if you notice, um, um, they have different sessions for all of the sections that we have, for all of the topics that we have talked about in AP Physics this year. Okay, now if you guys notice, the first session starts today. So this is Monday, April the 19th. So the first session starts today, and they're going to be reviewing kinematics. So guys, I would very, very much recommend that you guys use this as a resource because these videos these are official videos that come from the College Board. These are the people that make the AP exam. So since they're doing this live review session, I would highly recommend that you guys um, attend all of these review sessions if you are serious about taking the test. Now, the one that's today, if you click on it, as you can see, it's going to take you to a YouTube. Well, it's going to take you a link. Well, the link is going to take you to the YouTube channel for AP Physics 1. And notice what it says. It says the first live session starts at 5 p.m. today. Now, guys, even if you are not able to make it to these live sessions, these videos will be recorded, and you can always go back later on and rewatch the videos, just to be sure that you're doing what you need to do to get prepared for the test. Now, here's what I would do, guys. If I were you, notice how there's a total of 8 sessions for AP Physics 1. What I would do, since we have 2 weekends prior to the test, if I were you guys, I would watch 4 videos a weekend. So I'll probably spend Saturday night going through 2 videos, spend Sunday night going through 2 videos, and then the next weekend do the same thing again. Spend Saturday night going through 2 videos, and spend Sunday night going through 2 videos. So I would kind of just like, um, um, split up my time evenly and spend the weekend going over these videos, for those of you guys who want to prepare for the AP exam. Okay, now there's something important that I need to state here. As you guys know, because we are working virtually and because every school has different schedules, the College Board knows that, that there's no one school that is perfectly on pace. Because this is a very strange year. We are in the middle of a pandemic, so this is just a very different year. So that's why the College Board um, um, has made these videos to assist you guys. This is to assist the student and to assist the teacher. Now, guys, because we are a little bit behind, 2 of the topics we're not going to get to in time prior to the AP exam, and I want to tell you guys what those 2 topics are. Those 2 topics are simple harmonic motion and rotational kinematics. Okay, so guys, please definitely look over YouTube videos and also these review videos on these 2 topics. I will spend my weekend focusing on that, because we're not going to have time to get to these 2 topics before the AP exam. Again, this is just the way the school year's been. Um, all of us AP teachers, we've all gotten a little behind. So because I'm not going to get to these 2 topics, I would very much recommend that you guys learn these 2 topics on your own. Okay. Everything else we've talked about or at least introduced. But these topics, simple harmonic motion and rotational kinematics, definitely spend time looking over that. Okay. And again, guys, this 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 page right here, I am going to put in Schoology so that you guys will have these links that you can use later on whenever you're preparing for the actual AP test. Uh, are there any questions for me regarding these AP live sessions or regarding the AP exam? Any questions? Anyone? Guys, in my last class, some students asked me, "Will you guys need to bring calculators?" The answer to the question is no. We're going to provide calculators to you all. Um, just know, be here that Wednesday morning so that you guys will be ready to take the test. But we will provide calculators for you all. And again, the link to those review sessions I am going to put in Schoology. I would definitely recommend that you guys go over that because again, those videos were made by the people at the College Board. So these are the people that actually make the exam. So please go over those when you guys are free. Okay. Any questions before we get started? All right. So with that said, um um let us discuss what we are going to be doing today. Thank you, Angelina, for posting the attendance form. Um, okay, so on today, um, we're going to be talking about work and power. So we talked about energy last week. We're going to talk about work and power this week. We're going to also get started with momentum and impulse. And the momentum and impulse topic will probably take us up until the end of next week. So just before you guys take the AP exam. Okay. So we're in fourth period. click on the Materials tab. Fit 6 weeks. And it is, today is April the 19th, and it is a Monday. Okay. So here's what we're going to do today. Today we're going to actually talk about some pretty simple concepts. Work and power is pretty simple. As long as you know how to do the equations, you guys should be fine. So we're going to go over the work PowerPoint first, do some example problems. Then I'm going to go over the PowerPoint. And then as soon as we get done with the example problems there, I'm going to open up the assignment for you guys to complete, which is titled the Work and Power assignment. So just be paying attention while we're going over these examples, and then you guys should be ready to do the assignment in Schoology. Okay, so let me go ahead and open up the Work PowerPoint first. I'm going to open it up in Kami. That way I can write, that way I can annotate the page. Okay, for this topic for today, there are just basically two equations you guys are going to need. And with using these two equations, you guys should be able to do every problem in the assignment. So let's start with work. So the best definition of work is this third bullet point right here, where it says work occurs when a force moves an object over a certain distance. Okay, so remember last week we talked about energy. Okay, and one of the definitions of energy is the ability to do work. So that's what energy is, the ability to do work. But what exactly is work? So whenever physicists talk about work, this is what they're talking about: a force that causes an object to move over a certain distance. Anytime you have an object and a force is applied to it and it has a certain displacement, we say work is being done on the object. So that's very important, guys. You have to have the object move a certain distance in order for work to be done. So let me give you an example of what I mean by this. So imagine this stapler right here. So I have the stapler right here sitting on my desk. Okay. As you guys can see, I'm currently pressing down on the stapler. So I'm pressing down on the stapler and I'm pressing as hard as I can. But I noticed that the stapler isn't going anywhere. So you guys, even though I am applying a force on the object, that doesn't mean that I'm doing work on the object. Okay, so this is how physicists define work. In order for work to be done on the object, that object must have a displacement. So I'm pushing down on the stapler, but it's not going anywhere, so I am not doing work on the object. But guys, what if I push on the stapler from this direction? So notice as I push on the stapler this direction, notice how the stapler moves now. So because the stapler had a displacement, since the displacement went from here to here, then you can say that I've done work on the object. Okay, so everybody got that? So please keep it in mind. Just because you are applying a force on an object does not mean you're doing work on an object. Physicists say in order for you to be doing work on an object, the object must have a displacement. So it must travel some distance. Okay, so hopefully everybody got that. That's important to know about work. So with that said, here's the equation for work. I'm just going to write this down. The mathematical equation for work is equal to force times distance, or in other words, force times displacement. Okay. So this is the mathematical equation for work, and this is what you guys are going to be doing. This is the equation you guys are going to be using today whenever you're doing those problems in Schoology. Okay. And one thing I want to say, guys, whenever you're looking, whenever you're doing this assignment, it's important that you guys get your units right. Work is the standard unit for work is in joules. Okay, the standard unit for work is joules. So just so you guys know, the same unit that we use for energy, that's also the same unit for work. which makes sense, right? Because energy is defined as the ability to do work. So they are related to each other. So just as energy is in joules, work is also in joules. Okay? And as you guys know, force is in newtons and distance is in meters. Okay, so just something to keep in mind. Um, one more thing that I want to say here before I move on to example problems. Know that positive work gives an object energy. In other words, positive work puts energy into an object. Okay, so if positive work puts energy into an object, that means negative work must take energy out of an object. Okay, so if you give an object energy, you've done positive work on the object. If you take in energy away from the object, then you've done negative work on the object. Let me give you an example of what I mean by that. So imagine someone throws me a baseball, and I take the baseball and I catch it, and I bring the baseball to a stop in my hand. So, guys, as long as that baseball is coming at me, as long as it's flying at me, it has kinetic energy because it's in motion. If I reach my hand out and I catch the baseball and I stop it, we would say that I did negative work on the baseball. How do I know that? Because I brought the baseball to a stop. I took energy out of the baseball. Because it came to a stop, kinetic energy came out of the baseball. So I did negative work on the baseball. Okay. So remember that positive work gives an object energy, negative work takes energy away from an object. Just a little factoid to keep in mind. Okay. So with that said, let us just do some examples here. Look at this first example. So this first example says, how much work is required to push with 300 newtons of force a box 10 meters across the floor? So remember what I just said. Work is defined as force multiplied by displacement. In other words, force times distance. Okay. So guys, if I have an object, okay, I push with 300 newtons of force, and the box slides 10 meters across. What is my work done in this case? Well, 300 times 10, that gives me what? Anybody want to put a check box? Y'all should know that. That's really easy. 300 times 10 is, thank you, Angelina, 3,000. And remember, Angelina, always put your units, 3,000 joules, right? The same, that's the main thing I want to focus on here, guys. The same unit for work is also the same unit for energy. It's in joules. Okay, so we got that. All right, let's look at this second question. It says, if a person does 200 joules of work to slide a box 2 meters across the floor, how much force was acting on the box? Okay, so let's plug everything in. So if work is equal to force times distance, they tell us that the work done was 200 joules. So I'm gonna plug in 200 for my work done. Okay. We're trying to solve this equation for force, and we know the displacement. The displacement was 2 meters. Okay. So how do I solve this equation for force? Y'all know that. I need to divide my right-hand side by 2. That goes away. Whatever to do on one side, I have to do to the other. So guys, what's 200 divided by 2? So in other words, what is my force here in this case? And please be sure to put the units in the chat box. Yes, thank you, Angelina. 100 newtons. That's what I was looking for, 100 newtons. Yeah, guys, so your units are important. Okay. All right, guys, let us do 2 more before we get to power. So look at this question right here. The third question says, if a person does 300 joules of work with the force of 150 newtons, how far did they move the object? So how far? In other words, it's asking us to solve for distance. So let's plug everything in. They tell us that the work done was 300. They tell us that the force was 150. And they're asking us to solve this equation for distance. Okay. You guys know how to solve this equation for distance. We have to divide both sides by 150. So that's divided by 150. Then whatever do one side, we have to do the other. So guys, someone tell me what's 300 divided by 150, and then give me your answer in the correct units. Yes. That's what I'm looking for, 2 meters. Thank you, Angelina. Yeah, anytime we're solving for distance, we are in meters. Okay, last one on the work PowerPoint. This question says, a man weighs 800 newtons. He climbs a ladder and travels 300 meters upward. How much work did the man do to get to the top? Okay, so work done is equal to force times distance. Okay, so guys, in this case right here, I want you guys to imagine what's happening here. If this guy's climbing a ladder, it should be obvious to you all that he's doing work against gravity to get to the top. So he's done work against the gravity. He's done work against gravity. So, in other words, how much gravity is he acting against? Well, remember, guys, his weight is 800 newtons, and one of the things I told you guys last semester that work done, I'm sorry, that weight is equivalent to the force of gravity acting on the object. So that means, guys, as this guy climbs the ladder, he's doing work against 800 newtons of gravity. Okay, so he's climbing up against 800 newtons of gravity. So what we're going to plug into this force equation is 800, right? Because that's the force that he's acting against to get to the top. So the distance that he's climbs is 3 meters. So what's 800 times 3? How much work did he do to get to the top? I mean, how much? Yeah, how many joules of work did he do to get to the top? Yep. Thank you, Angelina. 2,400 joules. Okay. So guys, everybody got that? So guys, anytime an object is going against gravity and they give you the object's weight, know that's equivalent to the force that object is acting against. Right? The force of gravity is the same thing as the object's weight. Okay, so the last thing that I want to talk about today is power. So let me pull up that PowerPoint. That's called power. Okay, so power. Um, how do physicists define power? We've already talked about how physicists define work, but how do they define power? Guys, basically, power refers to how quickly work is being done. Textbook definition is that power is the rate at which work is being done. So, in a nutshell, the equation for power is this. So I'm gonna write this down. The mathematical equation for power is equal to work done by an object divided by the time it takes to do the work. So power is work divided by time. Okay. So this is the equation you guys are going to be using whenever you're calculating the power output of an object. Also, I want you guys to notice that in physics, the standard unit that we use for power is the watt. So whenever you're writing out, whenever you're working on power problems, you're always going to put that in watts. You're always going to put that in watts. So, guys, I want to explain power to you guys conceptually so you guys can understand how to recognize when one object has a greater power output compared to the other object. So let me show you guys what I mean by this. Let me give you guys a hypothetical example here. So let us imagine that we have two guys climbing a really tall building. So let me kind of draw my building here. So we have a building. Okay. let me draw me some windows. Here's the door to the building. Okay. And let us imagine that two guys are climbing up this building. So this building has a ladder. So there's a ladder to the top of this building. Draw my ladder. Again, I want to explain power to you guys conceptually. So we have two guys climbing this ladder here. So we have one guy, let's say we have one guy in green. And we have one guy in red. Guys, and let us assume both guys have the same weight. So, I don't know. So let's just say this guy weighs 40 newtons and this guy weighs 40 newtons. And so that means if they have the same weight and they're both climbing this building, that means they're going to be acting up against the same gravitational force, meaning they're going to do the same amount of work to get to the top. Okay, so both objects have the same amount of both guys weigh the same, so they do the same amount of work to get to the top, right? Because they're doing work against gravity as they climb. And guys, if the height of this building is 10 meters, so if this building here is 10 meters, then that means this person right here, well, that means both people, they do 400 joules of work to get to the top of this 10-meter building, right? Because 40 times 10 is 10. Guys, let me ask you a question here. If the guy in green takes 4 seconds to get to the top of the building, and the guy in red takes 2 seconds to get to the top of the building, can someone tell me which of the two individuals were more powerful? The one in green or the one in red? What do y'all think? Y'all want to tell me in the chat box? So they both weigh the same, meaning they do the same amount of work to get to the top. But who is more powerful, the person in green or the person in red? The person in green takes 4 seconds to get to the top. The person in red takes 2 seconds to get to the top. Who's more powerful? Anyone? Yes, Angelina. The person in red is more powerful because even though they did the same amount of work, the person in red did it in less time. In fact, I want you guys to see this here because remember what remember what power is. It's work divided by time. So if I take 400 joules and divide that by 4 seconds, 400 divided by 4, that gives me 100 watts for this person's power output. But what about the person in red? What is their power output? They did 400 joules of work, but they did it in 2 seconds. What's 400 divided by 2? 400 divided by 2, well, that is 200 watts. Okay. So what do you guys see here? The basic idea behind power is that whoever does the same amount of work in less time is considered to be more powerful. Yes, thank you, Stephanie. It's 200 watts. Yeah. So just something to keep in mind. So both people weigh the same, therefore they do the same amount of work to climb this building. But since the person in red did it in less time, he is considered to be more powerful. So does everybody understand how physicists define power? Okay. So that's what power is. It's the rate at which work is done. Okay. And that's what we see here in the PowerPoint. Like if you go back to the PowerPoint, it says, so a machine that works quicker, meaning it does it in less time, is considered to be more powerful. So everybody got that? If you have two machines and both machines are doing the same amount of work, the machine that does it in less time is considered to be more powerful. So that's how physicists define power. Okay. So with that said, let us close today just by doing 3 examples. We're just going to do 3 examples here, and then I'm going to let you guys go. So let me first write down my equation. Power is equal to work done divided by time. So look at this first question right here. It says Joanne did 2 joules of work and she did it in 5 seconds. How much power did she use? Well, so the work done that she did was 2 joules. She did it in 5 seconds. So what is 2 divided by 5? Anyone? Yes, thank you, Angelina. And the unit is watts. You're welcome. So yeah, anytime you're talking about power, you're talking about watts. Point 0.4 watts. Thank you for the answer though. So this next question says a 400 Newton person ran up a flight of stairs with his books, which was 10 meters high. If it took this person 30 seconds, what was their power output? So, guys, power is work divided by time. But remember, guys, remember the equation for work. Work is force times distance, right? So force times distance divided by time is also an equation for power. Okay. So everybody got that? So you can use one of these 2 equations for power. Either this equation right here, force times distance, or you just do work divided by time. Right? They mean the same thing, right? Because work is force times distance. Okay, so with this said, guys, look at Joanne. They give us her weight. She weighs 450 newtons, so that is the force of gravity that she's going against as she's run up the stairs. So in order to calculate her power, it's just 450 newtons, which is the force of gravity she's running against, times her distance. She ran a total of 10 meters. Okay. All of that divided by 30 seconds. Can someone tell me what you guys get for this person's power output? Yeah, that's what I yeah, that's right. Thank you, Angelina. I accidentally wrote the units wrong on my paper. Thank you for correcting me. It's 450 watts. Let me correct it. I can't believe I wrote the wrong units on my paper. Okay, that's better. All right, guys. Let us look at this last one. This last one says how much work is being done using a 45-watt light bulb for 2 hours. Okay, so guys, we know that power is equal to work divided by time. Okay, so we know that. So, and they tell us that the light bulb is 45 watts. So let's plug that in for power. We're trying to find the work done. We don't know that. But guys, what do I plug in for time? Now, I want to say something here that's very important that students don't make this mistake. Guys, notice here how the time is given in hours. But guys, anytime you're using this equation, you must always put your time in seconds. Please remember that. So I need to convert 2 hours into seconds. And guys, you can easily go to Google to do that. So if you just go to Google, type in 2 hours to seconds, and notice Google will tell you. Google tell you there's 7,200 seconds in 2 hours. Yeah, you did minutes, Angelina. That's fine. yeah, you did minutes. If there were minutes, but we're doing seconds. So you're fine. You're good. So I'm gonna plug in 7,200 seconds, right? Because that's according to Google. 2 hours is 7,200 seconds. So now, guys, how do I solve this equation for work? Y'all should know this. I would multiply both sides by 7,200. That goes away. Whatever to one side, I have to do to the other. So 7,200 times 45 gives me my work done. Can someone tell me what y'all get there? Along with the right units? Angelina, your number is right. But remember, newtons is the unit for force. Whenever I'm looking for the units for work, is joules. Okay. Yep. But thank you. Someone sent me a private question. Someone asked me where did I get the 7,200. Guys, the 7,200 is what you get when you convert from hours to seconds. So 2 hours, if I go to Google and I convert from hours to seconds, 2 hours is equal to 7,200 seconds. Okay. Okay, so let me go back to that. Let me zoom that out so I can let you guys write that down in case you guys want to write down the formulas and write down the answers. All right. Any questions on work or power? So please remember your units as well as the equations. Okay, guys, are there any immediate questions for me before I let you guys go? You're welcome, Angelina. It's going to be due today. It's actually not that bad. It's 12 very simple questions that involve using those equations. In just a moment, as soon as we get done with the Zoom call, I'm going to make it open to everyone. Guys, please fill out the attendance form if you have not done so. Guys, if there are no immediate questions from me at the moment, you guys are free to go. Enjoy the rest of your day, everyone. Bye,
You
guys.
too.
All right, take it easy, Jeremiah.
All right, you too.